All right. Sets. When we look at sets, look at it as a bag containing elements, and you're taking out things from that bag. That's how you look at sets. So I have a specific set, but before I begin, let me give you two very important notations. The one that looks like a U means the union, and the one that looks like an N or the smiley parabola is union, and the frowny parabola is called the intersection. Now, to give examples on both of them, I have the set A containing the numbers 1, 2, and 3. I have the set B containing the numbers 3, 4, and 5. Yes? So I have one bag, wegi number kersau, 1, 2, and 3, and the other bag has 3, 4, and 5. I start with intersection. A intersecting with B. That means I need to look at a number that occurs in both sets. Which number occurs in both sets? That number is 3. So the intersection of A and B is 3. So how do you write it? The intersection is 3. That is the answer. 3. That's the answer. So let's take another example. First, you learn it like this. What do you mean? Yes. This is how you look at it in the beginning, and then we will go forward and doing Venn diagrams. The things with the circle you said. Those are called Venn diagrams. We take the same example again, but in this case, we use union. So I have two different sets. I would like to join them together. Now, taking into consideration, in both bags, I have the same number, 3. So when I place my answer, I only write 1, 3. Both of them have 3, but I only use 1, because I only need 1. The union of both. Yes, thank you. Thank you. Yeah, so the union of set A and set B, 1 to 6. And that's how you write it. Easy peasy. Now, the next thing in sets is called the complement of a set. Again, I keep taking the same example over and over again. Two sets, A and B. I have two sets, A and B. I would like to know the answer of A apostrophe, the complement of the set. So what is A apostrophe? A apostrophe means everything that is not in A. I would like all the numbers that are not in A. Sorry? What is empty? This?
Aqui não. Linha aqui.
Yes, that's what we're doing right now. Here. A apostrophe. Yes? That is called the complement. So A apostrophe is defined as everything not in A. So the first step is look at what's in A. A is 1, 2, and 3. 1, 2, and 3. Remember, I'm looking at both sets. I want everything that's not in A. If we look at the number 3, it is in B, so I cannot count number 3. So what does it mean? The answer to A apostrophe is 4 and 5. That's it, because that's the only two things that are not in A. You can also say it with B. Give me the answer to B apostrophe. Everything, all the numbers that are not in B. So your answer is 1 and 2. Everything that's not in B. Yeah? And now we move on to the circles. Venn diagrams. And a really good exercise for this one is 6C, if I'm not mistaken. Page 139. Exercise 6C2. 62. That one identifies technically all the problems. And then we proceed. So I have to make this 7 times. Let me make this smaller. Let's move these a little bit. Yes, I'm making this 7 times. Easy peasy. Look at that. S and T. First question. S intersecting with T. That's our first question. Throw this away. S intersecting with T. Yes? Do you remember what the definition of this was, that means everything that's in S, the same numbers that are in S, and the same numbers that also appear in T. So, that is found in the middle. It's found in the middle. If it's found in S and it's found in T, it's in the middle. B, the union of S and T. So that means I count everything that's together in S together with T. Union, I add them together. I want everything that's in S and everything that's in T. So what do? You want everything that's in S and everything that's in T. That's what you want. Only the circles. You also have outside of the circles, which we will get into as well. Yeah, that's a question in here as well. C, S intersecting with T apostrophe. S intersecting with T apostrophe. What do you need to look for? S intersecting with everything that's not in T. S intersecting with everything that's not in T. So this is also in T. So this I do not need because it's also in T. Yes, outside as well. So the first thing I need is S. Start looking at that. All right. So one thing you should not forget is the outside of those circles, because this also counts. Everything that's not in T, the outside also counts. All right. Next year, I shall give visualize. D, T intersecting with S apostrophe. T intersecting with S apostrophe. So you can imagine, correct, nothing in S, correct. The same thing, reversed.
Pregunta, quem é o seu maior abini ayeron oggi? Basta ngedere si e contratta kita kurang party. Tori kantor bisa turin nai estang mayor ko bini ayera.
Quem todos maior não é?
Ask for about 15 of those.
9.
15. Who knows more people didn't get it and so forth. No, it doesn't matter. That's how they write it. It doesn't matter. Yeah, I can write S apostrophe intersecting with T. It doesn't matter. They wrote it like this. E, T apostrophe. T apostrophe. So what does that mean? Everything not in T. And if you notice correctly, you can write the same thing differently. Yes. Yes? So the last one, S intersecting with T apostrophe, is exactly the same thing as saying T apostrophe. So you can write differently, but meaning the same thing. Yes? So watch out for those things. E is the same as D, the same answer, just written differently. It's the same thing. Yeah, it's the same thing, written differently. Yeah, this one is T apostrophe, means the same thing. F, S intersecting with T apostrophe. So the first step is, this also has to do with a little bit of algebra. You have brackets. So what's the first thing you do? Look at the brackets. S intersecting with T. What is S intersecting with T? Here, in the middle. And what is left? You have apostrophe. So you're saying everything that's not intersecting with S and T. S intersecting with T means this in the middle was the first question. Here it is. Now you have apostrophe. Now that means everything that's not intersecting with S and T. So everything else. Yes, everything else. Here we go. Everything else. So union, and the last one is the union. The union, S and T. So, brackets. The union of S and T means both of those circles, everything. That's what it means. This is a union. No. This is what means the union, but it's the union apostrophe. So everything that's not the intersection, the union of them both. Yes. Is there a difference in what? No, there's no difference. Yes, sets. Extremely easy. If we can do 2, we can do 3. And a really great example of that, let me see if I can take it from another form. I've never tried it before.
Nah, si Melissa aqui, turmentor A ya Pak Tuna. Tur mayor, respuesta mayor A ya, para usar saco, você mayor A, respuesta pondrá usar mayor si el A ya. Si no, me se copia. Okay.
Yes, it works.
Puedo short com a mama no A ya. Okay.
Ele pode já não pode estar ubicado.
Quem torna seguro com a maior no A ya?
I was there. I didn't see any.
Just copy 15. Yes? 6D.
You people seem to go separately on this.
This one. Join is not here, if I'm not mistaken.
When is not here.
Yes, everything is there. (6D) 141. As soon as we're finished with this, we can go into the actual exercises and we are done with 6. It's extremely easy. The first question states, which members of the youth club play darts, chess, and table tennis? You have to do 3 things. So looking at the Venn diagram, these people have to be in darts, those people have to be in table tennis, and they have to be in chess. Which person is in all 3 of them? Clyde. Sonia doesn't play table tennis. It's outside of table tennis. Yes? Yes? Cleve is not. Oh, sorry, has all 3. B, darts and chess, but not table tennis. Darts and chess, but not table tennis. Correct. Sonia Blade, for those who play Mortal Kombat. The weakest person in Mortal Kombat. Sonia plays darts and chess, but not table tennis. C, which members play chess? Now remember the question. You have a club. You have a type of people. This is also has to do with a little bit chapter 12, the way you have to look at it. You have a group of people in the room, and they are split into groups. Some people like Clive play all 3, and so forth. Now, I say all the students who play chess, come forward. You do not only look at Dave and Greg. You look at everyone that plays chess. So David, Greg, Sonia, and Clyde, because all of them play chess. Yes? Sonia and Clive. Yes? D, darts only. So I have a group of students. I say, all right, if you only play darts, come forward. Only play darts. So you're not playing anything else. Not chess, not anything else. And that is Andy, and Tina. E, darts and table tennis, but not chess. So you play darts, you play table tennis, but you don't play chess. That is an empty set. That's no one. No one plays darts and table tennis but doesn't play chess. That circle is here. It's empty. You play darts and table tennis but not chess. Where are you? Here. There's no one in there. Darts and table tennis but not chess. Your one person in there plays darts and table tennis, but does not play chess. So you have to look at these two circles like this. Which person intersects with D, darts, and T, table tennis? No one. So it's an empty set. No one. That's the answer. No one. This one plays the all three. So then introducing something new is the empty set. You can write it like that, or it can be written like this. It's an empty set. Last one. Which person doesn't play any of these three activities? Correct. Yes? Paula. Paola plays all three of them. Yes? Correct. Plays probably something else. Swimming, whatever. Loves mathematics, stuff like that.
Transizioni bisogna lanciare.
So that is sets with three Venn diagrams. Moving forward to actual exercises you may get in an exam. Actual exercises. These are just introduction to what is sets, how to interpret it, how to read it, and so forth. 6.3 6.3 deals with questions you can get in exams. Specifically, I'm looking at example 6 on page 143. So when dealing with these types of sets, you will notice they will write, for example, something like this. NA. What is NA? All the number of elements in that set. So NA equals 15. That's how it will be written. NA is 15. If they're what? You have to write all the numbers. Yes? So, Luigi did a very good remark. In the middle means they belong as here as there. They belong in set A and belong to set B. And then comes the first question. Let's say these are the amount of students. A likes mathematics. A likes mathematics. And you can see immediately that B loves physics. Everyone loves mathematics. Yes? The question is, how many students are total in that class? Looking at the Venn diagram. No, this is the amount of students in a class. The situation or exercises come like that. You have an amount of students in a class, and they give you that Venn diagram. Bam. A, how many students are in that class? Looking at that Venn diagram. Sorry? No. So remember, 5 belongs to here and there. So if I ask a question, who likes math and who likes physics? Someone raises their hand. So, how do you go about this? The total number of students is 15 plus 7. That is already 22. And you still have those 5. And what does that mean? You add those 5 to them. Yes? How to understand it better? 15 people like math only. Yes? B, 7 people like physics only. And then you have the ones in the middle, they like math and physics. They like them both. Yes? We will get there. We will get to that one as well. Yes, yes. So the total amount of students in that class, 27. Let's get to complicated ones. Solving problems. Most of the exercises, if you are ready with sets, start making 6.5. If you can make 6.5, you understand sets. All right. In the factory is page 146, example 7. You have a factory. 100 shoes were tested. 12 were found to have faulty stitching. 15 had faulty gluing. And 4 had both faults. Find the number of shoes with at least one fault. One fault meaning either gluing or stitching. How many shoes had one fault? So they needed to have only faulty stitching and only faulty gluing. Correct. What do you mean? No, we're at the first one. You have 100 shoes that were tested. They say 12 had faulty gluing, and 15 of them had faulty. 12 had faulty stitching, 15 had faulty gluing, and total 4 of them had both. So, for example, let's say I have 4. Do you remember? This one is red. I say, bring all the ones that are red. You give these 2. I say, give all the ones that have green. You bring 3 forward. Yes? I say, bring the ones that have red included. You bring those 2, because they are red included. And then I say, bring the ones that have green included. You bring those 3. And then I say, well, one of them has red and green. Out of those, all the ones that I called forward. In total, the ones that are red were 2. The ones that are green were 3. But I do not have 5. I said 1 has both. Is green and red. So what do? You count the total, and what do? Subtract the one that has both. So how many do you have total? 4. That's what you're doing. Sorry? They say 4 have both faults. Both have 2 faults. Oh, 7. 146. 146. Yes, that one.
Anto, kinakwenta bira 4 Anto.
No, it's been told to you. Here.
Ya, pero
Yeah?
aquí no bisa, pero normal. Come lo si non lo bisa 4 Anto.
No, they will tell you.
Non bisa mi sempre.
Yes, of course, it can change.
Sì, passo,
It's not always the same, yes? Correct. Yes. They do not give you all the ones that have only one fault. They give you all of them. So you need to know the intersection. Yeah, but here it's 27. The ones with 2 faults are also included together with it. To get the answer. Because the ones with 1 fault are not given. Including the ones with 2 faults. In the question, 12 found faulty stitching, 15 faulty gluing, 4 had both. So when I say, bring all the shoes with faulty stitching, 12 come forward, bam. All right, send them back, send them to the back, all right. Bring me all the ones with faulty gluing, 15 comes forward. Now, I didn't say, does the one with glue also has bad stitching? I didn't say it, I said only glue, come forward. And then we noticed, hey, there are 4 out of all the ones we brought forward have 2 problems. So actually, how many shoes do I have total? It's 12 plus 15, subtract 4. Correct. That's the total amount of shoes. B. Oh, sorry. I. The second or the next one. Have no faults. Yes, 100 subtract 23 equals 77. All right. 23. 27 subtract 4. Yeah, 77. It's the rest. It's the rest.
¿Cuánto más es normal aquí?
27.
27. Hay 4 y está aquí. Hay 4 na no está contando?
Yes, yes, yes. Look at the question again.
Pero 4 na di 2. E 4 y está contando nada.
No, no.
Di ambos, di banda, di 2 banda acaba.
No, you have to look at the question again. Look, no. I always take an easier one to understand. We go again. These are shoes. I say, bring me the amount of shoes that has a red stain on them, right? Bring them forward. You say 2. You bring 2 forward to me. There they are. You go to the back with those 2. Then I say, bring shoes with green stains on them. You bring 3 forward. Yes? 3 of them you bring forward to me. Then you go back. I do not have 5 shoes. I do not have 5 shoes. I have 4. I only said, bring me those with red stains forward. You brought 2. Then I say, bring those with green stains forward. You brought 3. I do not have 5 shoes total. I have 4, but of course you don't know that. Correct. This one has both stains. And I tell you on the side, I have 2 with red stains, 3 with green stains, and 1 has both green and red stains out of all the ones I brought forward. So, how do I know how many shoes are there in total? You count everything together and subtract the intersection. So I have 4 shoes in total. Yes and no. When you say both, it has to do with the question. It depends what the question is. You say with both or yes or no. In the example I gave, it wasn't included. Everything is separate. In the example I gave, 5 was not in 15 nor in 7. It was completely separate. In this case, they say like this. A and B and the intersection is 4. You don't know what's in A and what's in B. So the question is, what is the union of A and B? That's the question. What is this? Give me the answer to this question. What is the union of A and B? It's not 27. Yes? The answer is not 27. No. Again. Union means, you remember? I go here again. If you have the same number, you do not include it again. So, you have a 4. That means you do not include the 4 in A and in B again. You subtract that 4. That is what you have. Yes, this is the same thing I did. Yes. Correct. And then you get exercises like example 8. As I said, when you can make chapter 6.5, you understand sets completely. In a group of 25 cricket fans, 16 have seen the West Indies play England, 8 had seen them play Australia, yes, and 4 haven't seen neither. Yes? There was a soccer or cricket match, 16 fans saw a certain game, 8 of them saw them play Australia, West Indies play Australia, and 4 was practicing mathematics. There's no time for that. They love mathematics. Show this information on a Venn diagram. That also has been done on a test. They give you the information, you have to draw it in the exam. That also happens. Yes. So, you, what is you? You is everyone. That's why you draw the big rectangle. That's everyone. 25. And E means played against England. You know that's 16. The other one for E, yes. And the ones who played Australia have 8. How many only watched West Indies play Australia? With this information, remember, 16 includes the intersection. 8 includes the intersection. Yes? So that means 16 and 8 together, there are some people who watched both games. That means in 16 and 8, people were counted twice. Yes, because if I add 16, 8, and 4, it's more than 25, and I only have 25 people. So, in that 16 and in that 8, I have a person or a few people that look at both games. You have to figure that out. So, how do you go about this specific problem? You know the intersection is X. It's an unknown number because you don't know how many people saw both games. You know that 16 people watched West Indies play England. So it's 16, subtract that what? Unknown that I do not know. Because those people watched both games. And the other one, the exact same thing. 8 people, subtract the amount of people that watched both games. It turns into algebra. This is set A. When you add X, because you have to add everything together, do not forget those 4 who didn't watch the games, who only played mathematics. And the total number of people should be 25. This is chapter 4, basic algebra. Add everything together. 16 with 8, 24. Min x at x equals 0 minus x. Oh, so I need to add 4. My apologies. It's 28. 28 equals 25. So how do I find x? And then x equals 3. So 3 people watched West Indies play Australia and played Australia and England. Multiplied by minus 1. I did 2 steps in one go. Now you understand why I write a lot? Because if I start skipping steps, you will say, oh, teacher, what did you do? Yes. Example 7. The total number of shoes that have faults that are not good are 23, not 27. We go back to this original problem. It's the same one. The only difference is I have 4 instead of 100. I say bring the shoes that have red stains. You bring 2 forward. Then you go back. Bring all the shoes that have green stains. You bring 3. You don't bring 2, you bring 3. How many shoes did you bring total forward? 5. Because first you brought 2 and then you brought 3. I do not have 5 shoes. You just brought 2 in the first set and then you brought 3 again. One of them has both stains. That's why you brought it twice forward. So how many shoes do I have total? Well, 4. Because the total subtract the one that has been brought up twice. I should subtract that one. And the one with the 100 shoes is exactly the same. You brought 27 forward, but 4 of them were brought twice forward. So you have to subtract those 4.
Mire, pero aquí no anda pizza con, si aquí no anda 5 personas diferentes. Aquí no anda 5 personas diferentes, ¿no?
In that case, yes. In that specific case.
Entonces, ahora no me both, que me manejo de 2 bandas a 4. Si no me sei, da que me di, aquí bandas de 4, da que me da 4 son mi taquita.
Yes, yes.
Entonces, aquí no está aquí, eso por los que había aquí. Também na Suminco School.
Yes, they. In this one, they said this is 16, like this. This is 16, and this is 8. And as you can see, it's included. So, two people in here were counted in here and in there.
Pues como él avisó también both que me da. Si no avisa me gusta both que me da única fue un momento.
Correct. They're already in it.
Pero aquí no.
And you have to separate them.
Aquí na turda dice Cuchete Kiko, também me tendo na conta Kiko na informação com na nome aqui na.
Yes, if it's written like this, you have to see what the information given. If it's just given blankly like that, then it's 15, 5, and 7. If it's blankly given like that.
Que me total.
Yes, the total is 15, 5, and 7.
Ah, pero como que no está combinado, pues ya no está incluido en tus dos bancos, me también hay 4 disquitos.
Correct.
Okay, entonces the walk
More questions? We have 5 minutes. All right. No more questions? I expect. These? Or the ones we just did? This you mean? Sorry? Use your completed diagram in question 3. So I have to make 3. Sorry? Oh, it's an example. It's example 8. Example 8. I give something like this in the exam, like exactly the same. Whole numbers from 2 to 60. Whole numbers are
Sorry, one random question. 1 liter is how many centimeters square?
square, not possible. You mean cubic centimeters?
Cubic. Sorry, yeah, I messed up the word. Sorry.
You have liter.
Would a cubic decimeter be 1 liter?
Correct.
I was gonna ask.
Then it means 1,000.
Cubic, not square.
E contesta aqui dentro me dá 3, então aqui na daqui dá 3 então 3, tá?
3, yes, yes.
Ok.
So how many people are only watched West Indies play England?
Mas aqui na buta de mais para mostrar que aqui quadra tá específico conexão aqui, então quadra é específico conexão aqui.
Correct.
Ok.
That's right. All numbers. Factors of 24. $36 and $60. First step, start listing the sets that include, yes, factors of 24. Remember last year, if I'm not mistaken, you included 1. I said specifically 2 to somewhere, and many people included numbers that were not included. Sorry? This is 142, exercise 3. So A, list all the numbers that belong to set A. Factors of 22 means every number that 24 can be divided by as a whole number. So start with 2. 24 divided by 2 is 12. 3. 24 divided by 3. 8. You have 4. 6. 8. 12. 24. All these numbers are factors of 24. B. Factors of 36. Again, 2. 3. 4. 6. 7, 8, 9. We have 12, yes. 13, yes. No, 13 is 39. No. 14, 15, 16, 17, 18, 19, 20. Then it goes all the way to 18. And then 36. 36. C. 2, 4, we have 5 as well, 6, 7, 8, 9, 10, 12. Is 14 included? No, 14 times. It's 5 times 70, no. 20. Nothing else? Yeah, and 60. That's all the numbers that belong to the set of C. Copy and complete the Venn diagram. Oh. Mm-hmm.
Instead of writing all the numbers in the circle, right? Can you press the C and the brackets only? Or just like a short route?
Just where?
Like instead of taking the long route, which was to put all the numbers in A, B, C,
Mm-hmm.
can you just like put A and brackets and then that's it?
No. You have to place all the numbers. So, I will highlight everything that's yellow that belongs to all three to make my life easier. Oops. Pink belongs to A and B. Oh no, 6 belongs to all three of them as well. Also yellow.
Also 12.
Yes. So, yes. So these 1, 2, 3, 4, 5 numbers belong to all three, which have to appear here because they belong to all three. So let me make this circle bigger. So we have 2. Oh, you don't see it very well. Uh, 12. And C. All right. Highlighted blue or pink belongs to A and B. That's it. Nothing belongs to A and B. A and B alone. So if you notice, the set of A and B is empty. This is A and B. Only A and B. It's empty. Nothing belongs to A and B. Now we need to look at A and C. A and C. Something that happens in A that also happens in C. Nothing. So this is also empty. Nothing belongs to A and belongs to C as well. Empty. Yes? Then I go for B and C. Does something happen in B and also happen at C at the same time? 9/1836. No. So this is empty. And then all you do is fill it in. Next. 8/24. B. 9/1836. 10, 20, 30, and 60. And are you finished? Of course not. No intersection. Are you finished? No. I place this exam, same question, shorter, in an exam. What is the U? The U are whole numbers from 2 to 60. So in this particular case, I need all numbers between 2 going all the way to 60. So, for example, the number 59 is outside. Yes? It's outside. What else is outside? 58. No. 2 to 60. And that's how you continue to fill it in. All the other numbers which are not in the circles. 40, 41, 42, all the other numbers. 29, 27, 25. Correct. Yes? All the rest of the numbers. 25, 7, 11, 13. All the other numbers that are not in here from 2 to 60 get placed outside. I think this exercise. Sorry? What do you mean? Correct, yes. All right. And then we move on to Keanu's question. 5. 6 is an element. Yes, I think I stole one. Six is a member, sorry, not element, is a member of PQ. Wait, huh? Why PQR? Oh, it's PQR. I did ABC. Ha!
Same thing.
PQR. It's PQR. Technically, yes. I just have to change the color, the letter. All right, 5. It's a good thing to place in the exam for next trimester 2.
Yay.
6 is a member of P and Q intersecting with R. Wow. So what am I looking for? P and Q have to intersect. What is P and Q? This is P and Q. And then it also has to intersect with R. So we're looking here. So that's what you have to fill in. This is what you have to draw. Does it say Satan? Oh, it's true. Oh, true or not true? Yes, yes, yes. True or not true? A is true. It is true. A is true. No, that E means is a member of. So it belongs in that area. Member of, yes. Because you also have another one. You also have means member of. And then you have this. Is element of. Technically meaning the same thing. The only difference is member of only has one number. It's only one number. When you see the other one, it has multiple numbers. Where? NT. So I could say, like here, NC. Means everything that's in C. You say NT, everything that's in T.
Ah, pero me decían los aquí un diferente.